In this video, we'll go over student-led example, t-test for two related samples. So please have your Chapter 11 practice problems out. We've already done the teacher-led example. I'd like you to pause the video, try it on your own, and then watch the video to see how you've done. So in this example, a teacher gives a reading skills test to a third grade class with an N of 25 at the beginning of the school year. To evaluate the changes that occurred during the year, students are tested again at the end of the year. Their test scores showed an average improvement of a mean difference of 12.7 points with a variance of 100. Are the results sufficient to conclude that there is a significant improvement? We'll use a one-tailed test with an alpha of 0.01. So part of the reason we're doing a one-tailed test is because we're saying that there's an improvement. We have a direction. So the first thing we need to do is state our hypotheses. So our hypothesis, our null hypothesis, is going to be, well actually I always like to go with my alternative hypothesis first when we're doing, especially when we're doing a directional test, is that my mean difference is going to be better than what's expected in the population. And my alternative hypothesis would be that the mean difference would be less than or equal to 0. We already have our alpha level, an alpha of 0.01 in a one-tailed test. So now we need to get our critical t. So if you remember from the example, we said we had an N of 25. That gives us a degrees of freedom of 24. Then N of 25, our degrees of freedom are 24. We're looking at 0.01 in one tail. Down there, we had our degrees of freedom of 24. It's going to give us a critical t of 2.492. So our critical t was 2.492. Now we're given our variance, so we don't have to do calculations like we did in the teacher-led example, but we need to get our estimated standard error of the mean difference. So we're going to take square root of 100, which is our variance, over our sample size. It's going to give me a square root of 4, or an estimated standard error of 2. I'm going to take that, I'm going to plug that into my t formula, which is going to give me 12.7, and we estimate that the mean population difference would be 0, so we don't need to put anything else there, over our estimated standard error, which would be 2, and that's going to give me a value of 6.35. But our critical t was negative 2.492 and positive 2.492. Our 6.35 is going to be way out here in our critical region, so we reject the null hypothesis. And how we would write that in the literature would be our t statistic with our degrees of freedom, our calculated t, and a probability of less than 0.01.